Good evening, everyone. We are Group 16, and our topic for the weekly presentation is Face Morphing Attack Generation and Detection, a comprehensive survey. My friend Pranavi will be giving the introduction and some details.
Biometrics is a technique to recognize an individual based on unique biological or behavioral characteristics. It could be a keystroke, a face, a fingerprint, a iris, etc. Ease to capture and suitability of the face biometric characters has further driven face recognition as a very popular applications. Face recognition systems are widely deployed for various applications for person identification, verification purposes, among other apps like healthcare, law and enforcement, e-commerce, banking, um, relevant applications in the border control process, where the face characteristics of a traveler is compared with a reference in a passport or a visa document in order to verify the claimed identity. Though face recognition system effectively distinguishes an individual from other subjects, the risk of being attacked to mislead or conceal the actual identity is the major concern. This system is also prone to various attacks such as presentation attack with a goal to subvert by presenting an artifact, and electronic display attack, print attack, replay attack, face mask attack. Yet these were not a big major of an issue, uh, but a morphing attack that has also emerged as a very big severe threat along with the enrollment process that undermines the facial recognition capabilities successfully. Face morphing is defined as a seamless transition of a facial image, transforming a face image into another. Two or more multiple facial images can be combined to resemble as one subject. Morphing attacks raise a major concern as the morphed images represents the facial characteristics of both to the morphing process contributing individuals. Eventually, the resulting morphed facial image can be successfully be verified from both the images. Therefore, the attack breaks the rule of single ownership, which scares as according to us, this is the most secure process. This is an example scenario in the border control where the facial image of a malicious person is morphed with a lookalike accomplice. So, as there are several morphing softwares freely available, even a non-technical person can perform morphing with ease. An accomplice that can submit the generated morphed image for passport enrollment at the passport issuance. As the morphed image features resemble the applicant's face, the passport officer approves the application. Eventually, a malicious person can successfully use the genuine passport, allowing him or her with all the purposes, that is of crossing a border, etc. The morphing process can be defined as a special effect that transforms one image into another image. The facial morphing process, where two facial images are combined together to generate a single morphed image. It can be easily achieved by using one of the numerous and freely available tools. Few of them are Morphing, 3D This, Face Morph, Face Swap Online, Obrusoft, Phantom Morph, Face Morpher, Magic Morph, etc. As you can see, in this figure, the morphed image can be equally verified against both the other subject with a high similarity score from facial recognition system. The morphed image near identical features with both subject contributing to generating morphs when subject pre-selection is applied. The morphed image does not possess many visible artifacts, and thus a human observer may fail to detect the image manipulation based on morphing. It triggers a reasonable condition where a criminal with malicious intent can use a passport enrolled with a morphed image and cross the border without any challenges. Face morph attack generation. Face morphing was widely used for over a decade, especially in video animation industry, but the attack potential on facial recognition system was noted in the recent past. Morphs can be generated using various techniques, from single image wrapping to recent generative adversarial networks. The most widely used morph generation is based on landmark based technique, where morphing is carried out by combining the images with respective to the corresponding landmarks. To be more precise, landmark based morph generations works on obtaining the landmark points on the face recognition. That is, it could be on nose, eye, mouth region, etc. These landmark points appear from those both faces are wrapped around by moving pixels to different, more averaging positions. And there are procedures used like wrapping exits, including freeform deformations and everything. Images that are not to be morphed are blended by considering the blending factors or the morphing factors. Face morphing application employs a morphing factors which is of like 0.5 to generate good quality and useful morphs that can resemble both contributes.
Thank you, Pranavi. So I'll be talking about morph face detection, attack detection techniques, and performance metrics. In human perception and morph face detection, the threat of morphing attacks is known for border crossing or ID management scenarios. Therefore, the success of a morphing attack depends on deceiving human observers, especially an ID expert or border guard. The practical scenario for a border crossing includes those border guards who compares the passport of traveler containing a photograph with their physical appearance. Thus, the border guard concludes based on the facial similarity of the traveler with the reference data in the passport for his final decision. Several studies have been concluded and an early investigation on human perception analysis of images was reported, where different experiments were performed to benchmark the ability of human observers to detect face morphing and its dependencies to various parameters. While this was an interesting work, the human observers in the experiments were students not trained to compare human faces. Further, this work is based on only one single image without providing any reference image for the human observers. A similar analysis was provided where a single image was provided before requesting a decision on morphine. Despite being different in the underlying benchmarking mechanisms, both works were reportedly difficult in detecting morph faces images by the human observers. Face morph attack detection techniques. Noting the limitations of human observers, a number of automatic morphing attack detection approaches have been proposed in the recent past. The available morphing attack detection techniques can be classified into two major types: single image based attack detection and differential image based attack detection. The goal of single image based attack detection is to effectively detect a face morphing attack based on a single image presented through the algorithm, where a facial image is submitted by the applicant for biometric enrollment in the passport application process. This submitted image is checked in order to detect potentially a morph of the suspect image. The passport application can be initiated by the applicant either physically when submitting his facial image through a web service. Thus, depending on the type of the use case, the morph image can be of two types: digitalized and redigitalized. The SMAT is challenging as it is expected to be robust to image quality variations. Different types of sensors, different type of morph generation tools, and different type of print scan processes are required. In differential image-based attack detection, the objective of differential image-based attack detection approach is to make a decision on the suspect image as morph or modified when a corresponding image is captured in a controlled environment. The knee-mat technique suits well for the border crossing scenarios with the suspect morph image can be obtained from the passport that can be compared against the live captured face image. The taxonomy of DMAT techniques can be broadly classified into two types: feature difference-based DMAT and demorphing. Performance metrics. Vulnerability assessment of FRS. For a morph image to be deemed as a significant threat to FRS, it is necessary to establish the threat potential. Most of the works provide the threat potential by measuring the vulnerability of FRS. Therefore, a brief overview of suitable metrics of establishing the relevance of morph attacks through vulnerability metrics. The goal of face vulnerability analysis is to measure if the generated morph face image can be verified against all contributory data subjects. Thus, when a morph face image is enrolled into a FRS and probed with another image from a contributory subjects, the FRS must successfully verify all contributory subjects corresponding to the preset verification threshold. In the most of the work, the threshold of the FRS has been adjusted to correspond to the false match rate. MAD performance metrics. The robustness of MAD algorithms is measured using the performance metrics defined in the international standard and are applicable to, to report the morphing attack detection performance. Since MAD performances can be visualized as a binary classification problem. Joint evaluation of MAD and vulnerability. In a real-life scenario, the FRS may operate with MAD subsystems in an integrated processing. For a successful attack, it is therefore important that the morph face images can invade the enrollment process and also will reach a match to probe images from the contributory subjects. To quantify the performance of the vulnerability in the presence of MAT, a metric called actual mated morph presentation match rate was recently proposed.
Thanks, Arvind. And hello, guys. My name is Manoj, and I would like to start the presentation with public evaluation and benchmarking. In this section, we summarize face morphing evaluations that publicly benchmarking morphing attack detection performance. These benchmarks have provided a common platform that includes datasets, evaluation protocols, and computational environment. The platform provides a trustworthy assessment of algorithms that can be obtained for submitting algorithms. In the following, we briefly describe the databases used in each platform and the performance achieved by various algorithms that are presented. The first one is morph performance of automated face morph detection. The morph test was first opened in June 2018 to provide a common platform for independent testing of face MAD technologies and to ensure a common assessment methodology. The dataset involved in the evaluation is created using different morphing methods, which have the objective to reflect low quality morphing, automated morph generation, and high quality morph generation. The evaluation is carried out for both SMAD and DMAD techniques. However, the probe data used in DMAD evaluation is not effectively stemming from automating border gates. And the second one is single morph attack detection. The Bologna server is also hosting a public benchmark for SMAD since 2020. The SMAD dataset is constructed using high quality passport images similar to the one used in Real Passport. The morphed images are generated using both commercial and open source face morphing software. Post-processing is carried out using automating and manual processes to overcome the artifacts generated using the face morphing software. Now coming to the discussion on public evaluation. Based on the above discussion on the publicly available benchmarks and competitions, it can be noted that the reliable detection of the face morphing attacks remains challenging. It can be pointed out that SMAD techniques' performance is severely degraded compared to that of the DMAD technologies. This can be attributed to the availability of additional information that can be used to make the final decision. The interesting outcome of these competitions indicates that the use of hybrid features based like SMAD technique has shown improved generalizability across various morph generation methods. At the same time, the feature difference method used in the context of DMAD has indicated a more robust performance in both the benchmarks. Now coming to the future works. The research topic of face morphing and detection has received greater interest from both research and government stakeholders. However, there are still several challenges and future work that need to be addressed, and I would like to address some of these in this section. And the first one is unavailability of large-scale public datasets with variation. The unavailability of large-scale face morphing datasets reflecting the real-life scenario hinders the development of robust MAD. Further, considering the different modes of morph attacks, it is necessary to generate and evaluate the MAD algorithms on digital and print scan datasets. Additionally, the datasets cannot be shared publicly due to license restrictions as well as to privacy and GDPR concerns. Hence, there is a limitation to accessing the existing morphing databases. And the second one is selection of data subjects for morphing. It can also be noted that in earlier studies, the morphing images are generated by randomly selecting the contributing data subjects. It is well established assumption that the morphing attack will be more successful with both human observers and machine FRS. If the candidate data subjects that are selected based on a lookalike measure. However, the systematic study of these existing methods towards the impact of the FRS vulnerability, the detection performs on both human observers and automatic MAD detection methods still needs to be investigated. And the third one is identical twins and lookalike. Influence of morphing on identical twins and lookalike is an interesting problem that needs a systematic study within the scope of morphing. The vulnerability of FRS due to face morphing image generated from identical twins and lookalike subjects need to be studied on the large-scale databases. And the last one is user convenience. The design of user-convenient MAD systems plays a crucial role in making detection subsystems deployable in real-time applications. There is a need to be design phase MAD system that allows minimum user intervention. This fact needs to be considered when designing DMAT techniques that are tailored for the ABC systems. Now coming to the conclusion. Face recognition systems have gained high amount of trust for security related applications. However, morphing attacks on face recognition systems can be a hindrance to establish a secure society. Further, there have been various morphing attack detection techniques being proposed by several researchers to effectively detect morphed images. However, improvements in the deep learning and machine learning techniques have resulted in a generation of high quality morphs using various new techniques. Hence, generalizing a morph attack detection is still predicted to be a long way ahead, considering the basic challenge of obtaining large public databases with variation and different morph generation techniques. Thank you.